But first two chapters are there. This one will
First,
also be there, I think.
this one will also be there in September, and they'll complete it in the school in a month. Huh?
Yeah, ma'am. They will complete in a month.
Okay, fine. So I think we'll actually pace it up. We'll actually
Okay.
we'll try to cover it up till September. Okay. Yes.
Yes,
Fine.
ma'am.
Yes. So Harshita, since this chapter is the fundamental of the actual chemistry that we are going to study, I first want to quickly take an idea. What do you understand from this atoms and molecules? Because some of this we have already discussed in the second chapter, right?
Yes, ma'am.
Yeah. I quickly
So,
want to know what exactly you have in your mind regarding this, and then obviously we are here to discuss it with you. Yes, please start.
so molecules are made up of atoms,
Mm-hmm.
and, and the atoms can be further divided into protons, neutrons, and electrons.
Fine. Good.
Then molecules, they create the matter and they join
Mm,
together.
okay. So molecules they create the matter. Okay. Why are you saying that molecules create the matter?
Because the particles like join together, molecule particles join together to create an object.
Mm-hmm. Okay. Okay. So can I say that atom is the actual unit which is like combining together? Is that true?
Yes, ma'am, it is true.
It is true. It is also true in case of compounds. Compounds are pure substances. Is that true in the case of
Yes,
compounds?
yes, ma'am.
What's the constituting particle in compounds? If they are pure substances, what's the constituting particle in compounds?
Cons-
That's molecules, okay? That's molecules. We have learned this.
Okay,
That yeah,
yes,
because
ma'am.
yeah, just a quick revision of that point. Let's say we
Okay,
have hydrogen here and we have oxygen here, right? These are
yes, ma'am.
single atoms. If we combine the same hydrogen atoms, we'll get the element of hydrogen, and that is well understood, right? And that is why
Yes,
we say that element is the the simplest form of matter. Basically, the form in which matter is found is elemental form, right?
yes, ma'am.
Yeah. Then let's say we have another element that is oxygen. Oxygen atoms combine together to give you the element of oxygen. Fine, wonderful. Now,
Uh,
if I combine both of these elements, the atoms of both of these elements in some specific fixed ratio and a composition by mass, yes, and what type
yes,
of bonding between them? Chemical bonding between them, yes. This will give
yes,
me another particle, which will be a particle on its own, a totally different particle on its own, having completely different properties from the properties of the constituting elements, right? Therefore,
yes,
if I have that particle now, let's say I have this one particle in which actually I have combined this, but this is completely different from this and from this. Okay. Now, if I
oh,
actually repeat this particle, let's say 10 times, okay, then I will get a substance which is in which the constituting particle is this, not these. Okay. Once we have
oh,
this, we are not even concerned with this because this has actually totally gone, right? And that is what a
yes, ma'am.
compound is. Good. Now, see. So coming to back to our chapter that is atoms and molecules, as you rightly said, that atoms we know are actually further divisible into subatomic particles, electrons, protons, and neutrons, whereas molecules you defined as group of atoms, right?
Yes, ma'am.
Fine. And we have already discussed this somewhat in the second chapter that molecules are of two types, elements and compounds. Correct?
Yes, ma'am.
Fine. Now see, Harshita, this chapter will be dealing with some of the topics I'm writing here, okay, so that you are able to have
Okay,
an
ma'am.
idea. Okay. So basically, we'll be somewhat dealing with the history of atoms. Okay, history of
Yes,
atoms.
ma'am.
Then we have laws of chemical combination. Okay, very important laws. The
Okay,
basics
ma'am.
of modern chemistry. Right? Then
Yes,
we
ma'am.
have very important Dalton's atomic theory. Very important.
Okay, ma'am.
Mhm. And this also will be in this also we'll be studying very more important than the atomic theory. We have the drawbacks of this atomic theory. Okay, so that is even more important. Drawbacks of clear. Then coming
Yes,
on
ma'am.
to the main part that is symbols, elements and symbols,
Okay, ma'am.
elements and symbols. Then we have obviously the modern then we have the initial one and the modern symbols. Very important. Okay. Then obviously I'll be discussing the first 20 elements. Then after that, the
Okay,
main
ma'am.
part that starts, atomic mass. Very
Yes.
important. Very. Then we have molecules. Okay. Okay. And obviously we have
Okay.
elements and
And
compounds.
compounds.
Yeah. And we have ions. Correct.
Okay, ma'am.
Okay. Then we have the molecular mass. Okay. And last, very, very important conceptual part of chemistry, mole count. Like this is the, some of the broad topics that we'll be discussing. Obviously, they have subtopics within them. So see,
Okay.
what I'll be telling you today is that, see, I want to discuss the laws of chemical combination after we have done, like we have understood atoms and the reactions. Okay. I'll be discussing them today somewhat, but not much in detail. Once we are
Yes, ma'am.
understood, like, we have understood atoms, molecules, and molar mass, all of that, then we'll be coming back to this. Okay. So today I'll be discussing the
Okay.
history of atom. Okay. Somewhat laws of combination, how actually they were derived and why were they actually there. Then will be obviously discussing Dalton's atomic theory, but very superficially, because I want to first make you and explain you the importance of atoms, and then you will be able to understand the drawbacks very easily. Fine. Then obviously elements and symbols. So okay, should we start, Bache?
Yes. Yes, ma'am. We can
Have you
start.
understood the chapter? Like what is it about? Very important,
Yes,
because
ma'am.
once you actually understand the what the chapter is dealing with, it makes it very easy to understand. Okay, fine.
Yes, ma'am.
First topic, Bache, that is history of atom. Do you have your NCRT with yourself?
Yes, ma'am. I do.
Fine. See, we have a very brief history. I don't want to go into that much of detail.
Okay, ma'am.
So let's start with the first one. That is, see, in this also we have two parts: the Indian one and the Greek philosophy. Okay, so from the Indian philosophy and from the Greek philosophy. I'm first discussing the Indian philosophy.
Okay, ma'am.
Yes. So first we had around at 5000 BC, Maharishi. Okay, it's 500 now.
Okay, ma'am.
Okay, Maharishi Kannad, who said that we have Padarth. And what was Padarth? That was simply matter, right? We have understood matter. So he simply called matter as Padarth. And he said that if we actually keep on breaking the Padarth, okay, we will reach a state that will be, which is called as Parmanu. Okay. And this Parmanu state will be that it cannot be further divided. Yes. We kept on dividing Parmanu, or I mean Padarth, yes, and then we got Parmanu. Okay. But according to Maharishi Kannad, this Parmanu is not further divisible. Clear?
Okay.
Okay. So I
Yes,
just
ma'am.
keep on breaking and we will get Parmanu. Clear? So this was the basic part.
Yes.
Now, what happened next? Then we had this second philosopher, Indian philosopher, Pakuda. Okay, but I'm sorry with the names. Katyayana. Okay, what he said that. So basically, he actually applied the same concept there, but he formulated it differently. He said that the padarth, basically, okay, in case of Parmanu, the Parmanu does not exist on its own alone. Okay, it exists as a combination of different Parmanus. Okay, and then we have the Padarth. And this we know,
Yes.
atoms they combine together, they give you different physical states of matter, right? So if we actually talk in terms of what we have learned right now, so he said the same thing. Okay, I would quickly want to go through the NCRT if you have your NCRT, so that I'm able to just share that point with you.
Yes, ma'am. I have the
Yeah,
insight.
yeah. See, yeah, Pagoda Katyayama elaborated this doctrine and said that these particles normally exist in a combined form, which gives us various forms of matter. Yes. And what are the particles that
Yes.
he's talking about? The same particles that actually were called as the Parmanu. See, Parmanu.
Okay, ma'am.
Yeah. And what is Parmanu basically? The last stage of division of the Padarth. The last stage of division of Padarth gives us Parmanu. Okay. So, and
Yes.
this second philosopher just formulated this doctrine, formulated this concept differently, and he said that they actually exist in some combination. Clear, bache? Any problem till here?
No, ma'am. I got
Fine.
it.
Then coming on to the Greek philosophers, they also said the same thing. They just changed the name. Indian philosophers call it as Padarth, okay? The Greek philosophers calling it as matter. And we have actually discussed matter, fine. See, around the same era,
Yes, ma'am.
ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, again the same concept, yes, dividing matter. So matter is Padarth, yes. A stage will come when particles obtained cannot be divided further. Yes. And so Democritus called these indivisible particles atoms, meaning indivisible. Fine. So
Yes,
atom
ma'am.
and parmanu, the same thing. Basically, in Greek, the word was atomos, which meant actually indivisible. So from there, the word atom has been derived. Clear? Now see,
Okay, ma'am.
all of these are philosophies. There was no proof, there was no law, there was no as such evidence to say that okay, these philosophies are actually true. These are just the see, I might have
Okay.
any thought and I might give it as a philosophy, that's it. Okay, that's a philosophy. So the difference between philosophies and law is that law has been proved, it has been established. Philosophy, no establishment, that's just a thought, that's it.
Okay, ma'am.
So these were the philosophies. Now, to actually establish laws in chemical sciences, we need proofs, okay? And from there on, the process of establishing laws started. People started working using these concepts, To prove these
Yes,
concepts, people started working. And from there on, we have our laws. And who is the father of modern chemistry?
uh,
Antony L. Lavoisier, okay? Because
okay,
he
ma'am.
actually laid down the foundation. Antoine L. Lavoisier laid down the foundation of chemical sciences by establishing two important laws of chemical combination. Lavoisier was the only one who actually said that elements are the basic form of matter, right? They cannot be
Yes,
divided further. Are you able to recall that? Lavoisier
yes,
has done a tremendous amount of work in chemistry, therefore he's called as the father. Fine, it's fine.
okay, ma'am.
Yes, coming to this. So laws of chemical combination, I would quickly discuss it just very superficially so that we're able to have an idea. What are the laws of first law? Any idea? Law of conservation of mass.
Okay, ma'am.
Law of, what do you mean by chemical combination, Harshitha? Why are we studying the laws
By,
of chemical combination? Yes.
by mixing any two chemicals together.
And just now, let's say we know it right now, okay? Let's try to understand it from their perspective. When Lavoisier
Yes,
gave these laws, what were the particles which were combining?
um,
Just now you have discussed it. In India, that was Parmanu, yes, and in Greek, that was atoms. So both of the philosophers said that they are the indivisible particles, but they cannot exist on their own, right? And they are in some combined form. So basically, how are they combining about those, about such things the laws were there? Are you able to understand it now? By chemical combination,
yes,
the
ma'am.
atoms and the Parmanus, they were not existing alone. They were existing in some combination, yes? Now,
Yes, ma'am.
on what basis were those combinations there? Why were those combinations there? Yes. So that was decided by this. I hope it's clear now.
Yes, ma'am. It is clear.
Fine. So both of them obviously given by Lavoisier. Okay. The first law
Okay, ma'am.
was law of conservation of mass. Right? Around 1744 or something like that. Please check it. I think it's 1744. Okay. So 1744.
Okay,
Now this law, according to this law, very simple point. But since we did not have this law then, so this law actually played a very important role. Now, according to us, it might seem very normal. Okay, the law said that mass is mass can neither be created nor destroyed. In simple words, the mass has to be same. Yes, the mass has to be same.
yes,
Okay,
ma'am.
the mass has to be same. And let's say we had two atoms combining here. Okay, along with three different
Okay.
atoms like this. In total, we have five atoms, right? So let's say the total mass, combining the mass of all these five atoms, let's assume, right, will give us
Okay.
around 50 grams, fine. Now, what is
Yes,
the, after the combination, what's the state? Let's say we have different atom and four of them have combined together, something like this, okay? Now, also the
yes,
total mass should be 50 grams, okay? The
50
combinations
grams.
might have been different, but the total mass should be conserved here.
Okay, ma'am.
So, in simple terms, total mass of the reactants should be equal to the total mass of the product. Total mass of the reactants should be equal to the total mass of the product. Let's say, very important
Yes.
example, let's discuss this. We have already discussed this thing. Let's say I take two atoms of hydrogen. Yes. Does this mean two atoms of hydrogen if I write it like this, H2?
Yes, ma'am.
And is this an element or this is a molecule?
Uh, this is an ma'am. This is a
Say that.
molecule.
Say that. Huh. How many atoms? Achha, very simple. How many atoms do we have here? H2.
Two
Two.
atoms here.
So more than one atom, right?
Yes, ma'am.
So clearly, first of all, it's a molecule. Right?
Yes, ma'am.
Now, what kind of atoms have been combined here? Same or different? H and H.
Atoms are combined.
Same. Can I call it as the element? Yes, Bachche, this is the
Yes,
element.
ma'am.
This is a molecule, but what kind of a molecule? This is the element. Okay.
Okay, ma'am.
Now, if I say I combine two atoms of oxygen, right? Two atoms of
Okay, ma'am.
oxygen, I get H2O, right? Now, the
Yes,
point
ma'am.
is that here we have two hydrogen atoms. Okay. So let's say the mass will be 2 into 1. Yes, we have already discussed this. Hydrogen atoms, one mass of one hydrogen atom is 1 U. Okay. It will give us 2 U. Mass of one oxygen atom is 16. Okay. Therefore, 2
16.
into 16 gives us 32 U. Okay. Now, what's the
Okay.
mass here? Mass here. We will have to calculate the mass of all the atoms combined. Yes. So 2 into
Yes,
1
ma'am.
plus 1 into 16, since we just have one oxygen atom. Okay. Does
Yes,
this
ma'am.
give us 18?
Okay, ma'am.
It is giving us how much? 18. And how
18.
much are we having here? Total mass of reactants is
30.
34 U, right?
Yes, ma'am.
Now, is that okay? Is mass conserved here?
Yes.
No.
No, ma'am.
That means if we have two here, we will have to have like this. Then now let's see. Now this is the second equation. Okay. Therefore, now I'm writing it here, the next point. Okay. Here the mass of the reactants will be how many hydrogen atoms now? 4. Okay. So 4 into 1, don't worry, I will be discussing this. How do we get this 4? Okay. So that gives us 4U. Okay. Now we have this. How many oxygen atoms here? 2. So clearly 32U. Okay. Now let's see
Yes,
the
ma'am.
mass of the products. 2H2O. That means 4 hydrogen atoms. That means 4U plus 32U. Okay. Why? Because 2 oxygen atoms now. Clear?
Yes,
Does
ma'am.
this is this same? Yes or no? Is
Yes,
it
ma'am.
conserved now? So that is what we mean by the conservation of mass. The total mass on the reactant side has to be equal to the total mass of the product side. Tell
Yes,
me, is
ma'am.
it somewhat understood, Bachcha?
Yes, ma'am.
And this will
Okay.
really help us when we are actually having the equations. Okay. So how do we know where does the atom go? We know it should be combined differently, but the atom should be there in the same equation. It should be there in the same reaction. Okay. It should not be that we have actually lost an atom during a reaction. Here.
Okay, ma'am.
Fine. So I will, if one last example, hopefully this can help us. Let's say we have a container. Okay. Let's say we have a container. We have two containers. Okay. And in the first container, we have this orange bar. Okay. And something like this blue colored bar, right? And in
Yes.
the third container, we have this pink color, something like that, right? Now what happens? I mix them. I mix them. And I get this pink colored, okay? Then I get this blue. Then I get this orange, fine?
Yes, ma'am.
No, this one, pink, right? So basically, what are we saying here? Will the total mass be same here? But yes or no? Let's say it was 50 grams. It was 30 grams. Don't you think here it should be 80 grams?
Yes, ma'am.
What is this? What is this?
So,
Conservation of conservation of conservation
mass.
of What do we mean by conservation of mass, Harshita? Now, will you be able to explain it to me if I ask you
Uh, ma'am, I
anything? But
can. Yes,
you cannot. Are you saying that you cannot? You can clearly, very clearly. Yes,
ma'am,
say
I
that.
can tell it, but not. But
Hmm.
I'm not that much clear with it.
Yeah, that's the point. You are not very clear. What's the confusion? I want
Yes,
to know
ma'am.
that. What's the confusion?
About defining the law of conservation of mass. Like how to define it.
Okay, As in, okay, tell me the concept. Is that clear?
Concept is clear.
So if the concept is clear, you can define it. What have you understood from the concept? First, define that to me. I will tell you the exact definition then.
Okay, ma'am. So
Yeah,
from the
good.
concept, I understood that if we have two masses and if we
Mm-hmm.
combine them together, we get a different mass, which is like
Different mass. We get a
it's the
different mass.
same mass, but like when we join it, will be the
Mm-hmm. Again,
that's
once
what
more.
I understood, ma'am.
Huh? Once more.
That's what I understood it.
No worries. See, simple words. Mass is conserved. What is meant by conservation? To protect, right? What
Yes,
is
ma'am.
conservation? That is the same thing. Mass is conserved. Mass is not lost. The same mass which was there initially should be the mass which we have after the reaction. That's it.
Okay, ma'am.
Okay. The mass will not be different. Okay. Mass will not be different. Mass cannot be different. How can the mass be different, right? The mass has
Yeah,
to be same. And that is what the law is. The mass is same. It's conserved. Okay. It's same.
okay.
Fine. Fine. Coming on to the next law of combination, that is the law of constant proportions. Fine. This we'll be discussing once we have understood making molecules, okay, and making the formulas. Clear? This is
Okay,
very
ma'am.
important, but once we have understood how to get a chemical formula, then we'll be understanding this. Fine.
Yes, ma'am.
Yes, fine. Very good. Now tell me, any confusion till here? These are very basics, the historical arguments, all of that. Any confusion till here? Anything as such that you have not understood?
No, ma'am. I understood everything.
Then we have very important delta atomic theory. Clear? Basically, we have a great scientist in the field of science and chemistry who was John Dalton. Okay, and what he did for chemistry, actually, 90% of the postulates that he said in this atomic theory were wrong. Okay, but
Okay, ma'am.
actually those drawbacks laid the foundations for the correct postulates, for the correct findings. Therefore, this atomic theory plays a huge role in the modern sciences and modern chemistry. Okay, so in
Yes, ma'am.
1808, this was given in 1808, very important. Okay. Now I'm opening the NCRT. If you have your NCRT, please open it. That we'll be able to
Yes,
understand.
yes, ma'am.
Acha, first thing, bache, when we are discussing the postulates, it cannot be written in any other way and from the way it has been written as. You should be
Yes,
very clear. Basically you have to memorize the the postulates of the theory.
postulate.
Okay,
Okay,
because
ma'am.
you cannot write it in any other way.
Yes,
Right?
ma'am.
So law of constant proportion we'll be discussing later, but when what delta Z is. So John Dalton, this history might be very important. Okay, so you should
Okay,
go.
ma'am.
Now, in 1808, he presented his atomic theory, which was a turning point in the study of matter. Clear? I don't know what problem.
Yes, ma'am.
Yes, Harshitha, is it audible?
Yes, ma'am.
Yeah,
Now
yeah,
you're on it.
yeah. Okay. So, according to Dalton's atomic theory, very important, all matter. Matter now you should be having in mind matter can be elements or compounds, anything. Okay. Whether an
Yes,
element, a compound, or a mixture. Again, mixture is also a matter. Okay, it's composed of a small particles called atom. This was the same thing that all the Greek philosophers and the Indian philosophers they were telling us. Okay, the same point here.
yes, ma'am.
Now, from this, he actually gave us these six postulates. The first point: all matter
Okay,
is made up of very tiny particles called atoms, which participate in the chemical reaction. This we already know. Okay. Basically, it is the atom which participates in the chemical reaction. The smallest part of the element is the atom, and that participates in the chemical reaction. Okay. Tell me, bache, any confusion in the first point?
No, ma'am. I got
No.
it.
Second, atoms are indivisible particles. According to Dalton, they were indivisible. Okay. Which cannot be created or destroyed in a chemical reaction. Now, the point is that atoms are indivisible or not. This we actually found out later that they are further divisible into some subatomic particles. Okay. But the point here that
Okay.
they cannot be created or destroyed in a chemical reaction. Let's take this example. Okay, let's say we have hydrogen here, 2 SO2. This was giving us HO2, H2O, right?
Yes,
Now,
ma'am.
this hydrogen was there as it is. The atom was there as it is, right? This
Yes,
oxygen
ma'am.
atom was there as it is. So, this point is also right that they were not destroyed or created in a chemical reaction. The atoms were there as it is, right? We know
Yes.
now know we have found out that they are further divisible. But in a chemical reaction, atoms were participating as atoms, okay, as whole
Okay,
atoms,
ma'am.
not in their subatomic particles. Are you able to understand what I'm trying to tell you here? Okay,
Yes, ma'am.
okay. The third point. So in this also, the second point, atoms are indivisible. That was wrong, but all other point is right. Yes. The third point,
Yes.
atoms of the given element are identical in mass and chemical properties. Okay, this was actually proved wrong. Basically, he said that let's say we have an element. Okay, let's say we have carbon. Okay, so let's say this is one carbon atom, this is one carbon atom, this is one carbon atom. All are same atoms. This is the atom of same element, right? He said that the
Yes.
atoms of the same element, let's say this is carbon, okay, the mass and the properties of the atoms will be same. Why will they be same? Because they are the atoms of the same element. That means they are the same kind of atoms, right? But that was
Yes, ma'am.
proved wrong. Fourth point. Atoms of
Okay.
different elements have different masses and chemical properties. Again, let's say this was carbon. We have nitrogen. Okay. So the atom here of nitrogen. So the atom of carbon and nitrogen will be different. Okay, the atom of nitrogen and carbon will be different. Now, if you actually see this point, this seems true, right? This seems true. The atoms of different elements should be different. But let's see what happens, okay? The fifth point, atoms combine in the ratio of small whole numbers to form compounds. Let's say, bache, we have this water, okay, formation of water. So atoms of hydrogen are combining and atoms of oxygen are combining, right? It's not that
Yes.
2.3 atoms of hydrogen are combining, or let's say 1.3 atom of oxygen is combining. In this H2O, there are two whole atoms of hydrogen and one whole atom of
Oxygen.
oxygen. Okay, they are there in whole numbers. It's not that 1.3 atom of oxygen, 2.6 atoms of hydrogen are combining. Are you able to understand this point?
Yes, ma'am.
Sixth point, the relative number and the kinds of atoms are constant in a given compound. Harshita, we have discussed this point in the second chapter when we actually were discussing compounds. Tell me, is what is the relevance of this point? Sixth point. Can you go through it again quickly?
Yes, ma'am.
What do you understand from the last point?
Um,
But please do not
means
hesitate.
the
Okay.
number of
Yeah.
means the number of atoms in that molecule would be constant. And
What kind of a molecule is he talking about?
maybe like when you take H2O, like the hydrogen is constant. Like it's like when we're joining H2 plus O2, then hydrogen will be constant and oxygen will be constant. The number will
What do
be.
you what do you mean by the related number here? Kinds of atom you explained, right? So when we are making water, we'll be taking the atoms of hydrogen and oxygen, right? That means the kind of atoms combining. Correct?
Yes, ma'am.
Is that what you were saying to me? Fine.
Yes,
Good.
ma'am.
Then can you please actually tell me the relative number? What do we mean by this relative number?
Means like it
Hmm.
is a
You know it.
particular number given.
No. What is that particular number?
Uh,
Acha, okay, if that's a particular number, that's right. How do we get that number? Can you give me any example where you can show me that particular number in a compound? The number of atoms, particular number of atoms?
And like in H2O, the 2 is constant, right? It's like only a particular number.
Okay, okay. Is
We
one
cannot.
also not constant? One atom of oxygen, is that also not a constant?
Uh, I
Mhm.
don't know.
You know it, but that's why I'm asking. You know it. Trust me.
Mm,
See, if I write H2O, okay, and if I write
Yeah,
H2O2, are these same compounds or different compounds?
ma'am, they're different.
They're different. The second one is hydrogen peroxide, okay? The first one is water.
Yes, ma'am.
The first one is water. And they have completely different properties.
Yes, ma'am.
Therefore, you were right what you were saying to me. You were just not getting the right terms for that. In case of a compound, which we have already discussed this, in case of a compound, we have a fixed ratio. And with that fixed ratio, we get a fixed composition by mass. Yes. If we
Yes,
have two atoms of oxygen, okay, the mass will be 32. Okay. Therefore, the ratio will be 2 to 32. That will give us 1 is to 16. And what is the ratio of mass that we have in water molecule? We do not have it as 1 is to 8? Yes. Do we
yes,
have it
ma'am.
as 1 is to 8? Yes. Therefore, 1 is also a constant. Okay. 2 is a
Yes.
constant. You are right. 1 is also a constant. Okay. So the combination is
Okay.
fixed. Okay. This point is simply referring to that how actually we studied the formation of compounds from different elements in our chemical bonding. Okay.
Okay, ma'am.
Tell me, Bache, any confusion in the last point?
No, ma'am. There's no confusion.
Are all the points understood to you?
Yes, ma'am. They're
Fine.
okay.
Now,
So, ma'am, I
very
have
important.
to learn all these 6 points.
You will have to. You will have to.
Okay, ma'am.
Somewhat you can change. While you if you have memorized it, obviously some difference can be there while you are writing. Okay, but you
Okay,
just
ma'am.
cannot change the postulates because that has
Yes.
been given as it is. Okay,
Yes.
the order might be up and down. That's also fine at times. At your level you might say that's fine. Okay, you might write, but see, start with the first point. If the first point is not there, all other points do not make any sense. Okay,
Okay, ma'am.
yeah. So that's it. Now, quickly coming to the drawbacks of the delta atomic theory, Harshita.
Yes, ma'am.
Now, what do you think would be the drawbacks here? First, can you share that one more time?
Drawback.
Yeah, anything that you have actually gone through the 6 points, 6 postulates of this theory. What do you think would be true? What do you think, according to you, is not right?
Um,
Any point, Bachche. One, so you know, right? You said that to me in the beginning. Hmm.
ma'am, in
You know it, Harshita. The first point is absolutely right. It's the
yes,
atom
ma'am.
which actually participates in the reaction. Okay, so let's just remove the first point from the drawback. Coming to the second point, is there any problem in the second point, Harshita? The first point of the second point, the first part of the second point.
Atoms
Hmm.
can be divisible, ma'am, but here it's given
Exactly.
indivisible.
He said that atoms are indivisible, but we know that atoms
Can be further
are,
divided to
yes,
protons,
yes,
neutrons.
divisible into subatomic particles. Yes, they are called as subatomic particles.
Yes, ma'am.
And what are these subatomic particles? Electrons, protons. Fine.
Yes, ma'am.
So this is the first. Read this other part of the second point. That is true.
Then-
Okay.
Yes, ma'am. So, which cannot be created or destroyed in a chemical
We
reaction.
know it cannot be created or destroyed, right? Atom will be there as it is. Let's say we are taking calcium. Okay. Let's say we are taking calcium oxide and we are reacting it with water. Okay. We will get calcium hydroxide. Okay. The atom of calcium is there as it is. See, we had this calcium atom, the atom of calcium is there as it is. We had this oxygen atom, we had this oxygen atom, we have two atoms of oxygen as it is. Yes. We had two atoms of hydrogen, we have two atoms of hydrogen as it is. So can I say that this point is right?
Yes, ma'am.
Good. Okay. The third point, what's the third point?
Atoms of a given element are identical in mass and chemical properties.
Okay, let's try to understand this. So I have already told you what does it mean. Let's say we have this carbon element. Okay. We have these three atoms of carbon. So according to him, the atoms of the same element are similar, right? In the properties and the
Yes.
mass. But that's not right. Basically, we can have, let's say this is the carbon element, okay? We can have carbon 12, carbon 13, and carbon 14. This simply means I am writing the masses of these atoms, okay? So we might have carbon atom which has a mass of 12 units. We might have a carbon atom which might have a mass of 13 units, okay? And we can also have a carbon atom which has a mass of 14 units.
14
Okay, bache?
units.
Although they are the
Yes.
atoms of same elements, but they have different,
Different
mass.
masses.
Okay, and they are
Yes.
called as isotopes. We'll be discussing this in detail. They are called as isotopes. Okay,
Okay,
so
ma'am.
I'm saying carbon 12, carbon 13, carbon 14 are isotopes of carbon element.
Yes, ma'am.
Carbon 12, carbon 13, carbon 14 are isotopes of carbon element. They are the atoms of the same. They are the atoms of the same elements, but with different.
Different masses.
Right? If you want to write it, you can quickly write it down. Then I'll be moving on to the next point.
Yes, ma'am.
Noted this down.
Yes, ma'am.
Fourth point. He said that the atoms of different elements are different. Yes.
Yes, ma'am.
Let's say we have calcium. Calcium is one element, right?
Yes,
Argon
ma'am.
is one element. Okay. Let's say this is the atom of calcium. This is the atom of argon. Okay. Now the masses
Okay.
would be different. Yeah. Because they are atoms of different elements. But both
Yes.
calcium and argon have same masses. Still, they are atoms of different elements. Okay.
Okay,
But
ma'am.
their atomic masses is same. So calcium is also
Yes.
40. Okay. And argon is also 40. Can I say that the masses of the atoms of different elements are same?
No, ma'am.
No? Okay. I'll explain this again. Yes, I will explain this again. Okay. So this black colored atom is of calcium, is like calcium atom, okay? And this pink
Okay.
colored is for argon.
Okay.
Clear? Although
Yes,
we
ma'am.
know the number of electrons and protons would be different. And if I might just ask you that I've already told you that the atoms are different if they have different number of electrons and protons. I think I've told you this. Yes.
Yes, ma'am.
Yeah, not only the atomic number is different, that means the atoms are different. Okay, so they
Yes.
are different atoms. They are different atoms because they have different number of protons. Just understand this point here. Okay, very important. They are
Okay, ma'am.
different atoms because they have different number of protons. Yes, but even though they are atoms of different elements, they might have same mass. They might have same mass, and this is the example. So the mass of calcium atom is also 40 units, okay? And the mass of argon atom is also 40 units. Clear? You can clearly see the black atom is different, the pink atom is different, but their masses are
Same.
same. And these are called as isobars to each other, okay? So calcium and argon are isobars to each other, okay?
Okay,
Isobars
ma'am.
simply means, simple point here, Harshita, they are atoms of different elements but have same masses. That's it. In simple,
Okay.
I hope this point is clear. So the presence of isobars have been found naturally, okay? And the presence
Yes.
of isobars actually says that the fourth point of this theory is wrong. Yes.
Yes, ma'am.
Are you able to understand this, Harshita? Please tell me.
Yes, ma'am. I can understand, ma'am.
What's the fifth point?
The fifth one, atoms combine in a ratio of small whole numbers to
Yeah,
form compounds.
yeah, that's right. Do you think that's wrong or do you think that's right?
Mm. Yes, ma'am. It is right.
Ratio is there, right? So let's say we have mm, any let's say we have sodium. So this is a compound, right? Sodium oxide, Na2. What is the ratio of the atoms combining, like from sodium element and from oxygen element? Can I say 2:1? Two atoms of
Yes.
sodium combining with one atom of oxygen. Is this the ratio? Yes, this is the ratio. Now the ratio
Yes.
is in whole numbers or in some points? Is it not in whole numbers? Yeah. It's not that
Yes. Yes.
2.1 atom of sodium was there and 1.6 atom of oxygen was there. No, it's not that. It's one atom and it's two atoms. If it's not one, it should be two. If it's not two, it should be three. It cannot be there in between. Are you getting it?
Okay.
There's no concept of decimal here.
Yes, ma'am.
Tell me, are you understanding this one?
Yes, ma'am. I can
So
understand.
therefore, the this postulate in the Dalton's atomic theory is right. Okay. Now the fifth
Okay.
point, the sixth point is regarding the compounds. We already discussed that. That is also true. Okay.
Yes, ma'am.
Tell me, have you understood that theory? And then have you
Yeah.
understood the drawbacks?
Yes, ma'am. I have.
Okay. Now, from this, all of this, what we have concluded that atom is the force or the unit, the particle which participates in the chemical reaction. Yes.
Okay, ma'am.
Smallest unit of element which participates in the chemical reaction is atom. Clear, Harshita?
Yeah. Yes,
Yes.
ma'am.
Now, what we are discussing now, the smallest particle of element which participates in the chemical reaction is
That is the atom.
atom. Yeah, that's the atom, right? That's it.
Yes, ma'am.
Fine. Now, quickly, we will be discussing about atom. Once we have established the historical arguments related to atom and what is the significance of atom, we know now that atom is the basic particle which actually participates in the chemical reaction. Okay, so once we are able to understand the properties and the characteristics and the behavior of atom, we will be able to understand the different reactions. Yes, does
Yes,
that
ma'am.
make sense? Now, what our job is, we are going to understand atom somewhat. Still, till day,
Okay.
science has not been able to understand atom. The researches are going on. Okay, so whatever we have
Yes.
understood, we are going to understand. So first of all, the shape at your level, we might just say that the shape of the atom is spherical. Okay. But I might just quickly tell you here that shape of the atom is not spherical. Okay. Further, when you will go higher level of chemistry, you will know that it's not spherical. But at your level, the shape of the atom is spherical. Okay. And the
Ma'am, what is the
size
atom's shape?
is still not found out. Okay.
Is still not found out.
Yeah.
Okay.
Yeah. Size. Okay.
Okay,
Now,
ma'am.
the size, so if the shape is spherical, let's say we have this, right? Somewhat like this. I can just draw the 2D part.
Yes, ma'am.
So how we will measure the size? Obviously, for that, we will have to measure the radius. If the radius is
Yes.
small, the sphere might be small. Yes, if the radius is bigger, the obviously the sphere is bigger, right? So the size
Yes.
is measured by measuring the radius. Okay. And the unit in which radius is measured, can you tell me what is that? That is nanometer. I will write it properly. I don't worry. That is
Okay.
nanometer. Okay, nanometer. And how do we denote this? Like this. Yeah. Now, what is nanometer? Any idea, Bachchan?
Uh,
No.
it's the size of the particle.
Yeah, that's right. It's the size of the particle. So I'll try to explain in this way. Let's say I say I have 2 meters of cloth. Okay. What is it?
Okay, ma'am.
I'm measuring the length, right? I'm measuring the length. If I say the
Yes, ma'am.
distance is like 10 kilometers, somewhere I'm measuring the length. Yes.
Yes, ma'am.
You know, we have different units. We have kilometers and then we have meters, right? And meter is for
Yes.
the smaller length, kilometer is for the longer length, right? But there is some relation between both the units, kilometer and meter. Why? Because both of them are measuring the length somewhere. Do you understand this point? Okay.
Yes, ma'am.
And what's the relation? If I say 1000 meters will give me 1 kilometer, right? Or 1 kilometer is equal to 1000 meters, correct?
Yes, ma'am.
But there's a relation, but both of them are, because why is there a relation between them? Because both of them are measuring the same thing, right? That's the length.
Yes, ma'am.
Okay. So can I see that the radius is also somewhat of a length?
Yes, ma'am. It is.
It's a length, right? But that's really small, really small. Therefore, nanometer, bache, 1 nanometer is equal to 10 raised to the power minus 9 meters. This is the relation between them. Okay,
Okay, ma'am.
minus 9 meter. Are you able to understand this, Harshita?
Yes, ma'am.
And let me just also clearly tell you that atom till date has not been seen. Okay, powerful microscopes, you are not able to see atom. We are just assuming from all the studies that have been conducted that it's spherical in size and this would be the size of the atom. It's measured in nanometers. Okay. Now let
Okay,
me
ma'am.
just clear you here that different atoms, that is atoms of different elements, will have different sizes. But the unit would be nanometers. Okay. Let's say your
Okay.
cloth is 2.5 meters, mine is 3. Okay.
Yes, ma'am.
Meter is same. I mean, the unit is same, that's meter, right? But
Yes,
somewhat
ma'am.
the length has been changed, right?
Yes, ma'am.
Therefore, in the same manner, the atoms of different elements might have different sizes, that is, might have different radius, but all the radius would be in the nanometer. Is it clear,
Uh,
Bachu? And
yes,
can we
ma'am.
have you understood the nanometer part? What is nanometer?
Yes, I have
If
understood
we
it.
divide 1 meter, if we divide 1 meter into 2, 3, 4, 5, 6, 7, 8, 9, into these many pieces, we will get 1 nanometer. Okay.
Yes, ma'am.
Are you able to understand this concept?
Yes, ma'am.
Relation
I'm
one.
able to.
Yeah. So that is about the atom. So we have discussed the atom. The is the fundamental unit. Okay. The fundam. Hello.
Ma'am. Yes, ma'am. I can hear you.
Okay. Yeah. So it's the fundamental particle basically which is participating in the reaction. And once we have understood that atom is the particle which participates in the reaction, we need to understand about the atom. So two things that we've discussed about atom is the shape and the size of the atom. Fine. Now,
Okay.
see, we have different elements. Okay. We have different elements. So actually it was Dalton. Let's say we have, oxygen. Okay. So let's say I'm combining oxygen with sodium. I'm just saying, okay, I'm combining oxygen with sodium, with magnesium, any number of elements that I'm reacting. I have to write all the elements like this, and that becomes very inconvenient. Okay, that becomes very inconvenient. Therefore,
Yes,
Dalton suggested, Harshita, that we should have some symbols for every element. We should have some symbols for every element. And quickly
okay,
open up
ma'am.
your NCRT. We'll be going through the symbols that Dalton gave.
Yes, ma'am.
Yes. So according to Dalton, Dalton suggested symbols for some elements as proposed by Dalton. So hydrogen, a circle, okay, and within that a small circle. So you can clearly see the symbols for every element here. Are you able to see them? Okay.
Yes, ma'am.
Now the problem is that when even if you are using these symbols instead of writing the full names of the elements, this is also very inconvenient, right? For
Yes,
example,
ma'am.
gold. Let's say it has 1, 2, 3, 4, 5, 6, 7, 8 strokes, right? Let's say instead of 8, I just draw 7. So that will make a mistake there. Yes. Mercury, it has
Yes,
8 dots. Let's say instead of dots, if I draw the strokes, okay? So that will again be
ma'am.
a mistake, okay? So therefore, these symbols, although they were proposed by Dalton to have some convenience in writing the equations and that, but further it created problems because these symbols were really complicated and not very easy to use, okay? Therefore,
Okay,
we had another scientist, J.J. Berzelius, who said that we had Berzelius who said that, writing it here, suggested symbol, okay,
yes,
and
ma'am.
they were actually rejected because of the inconvenience. Then we got modern symbols for elements. Okay, Berzelius suggested, it was J.J. Berzelius, suggested that we should write the letters of the name of the element as symbols. Okay, Berzelius
Okay,
suggested that we should write the letters of the name of element as its symbol. Okay, as its
okay,
symbol.
ma'am.
Now let's see this. What was the problem here? It was very fine. It was going very well. Let's say we have to write oxygen. Okay, instead of writing full oxygen, we just write O. It was very convenient, right? Even you will write O, even I will write O. That was convenient. Okay, much more convenient from the symbol that Dalton sir gave. But then what happened? Let's say we have hydrogen. We have, okay, I'm writing the full names here to make it clear. We have helium. Okay, both of them are starting with H. Let's say if I
Yes, ma'am.
take H for hydrogen and I take HL for helium, but you say that you will take HY for hydrogen and you will take H for helium. Okay. So now can
Yes,
you
ma'am.
clearly see that there was some difference in this also? Okay. Although
Yes,
we
ma'am.
were taking the letters of the element, the name of the element itself, but then also it was creating some confusion. Therefore, we have IUPAC. Okay. IUPAC, which actually decides the symbols for all the elements. Okay, which actually decides the symbols for all the elements, and therefore we have standard symbols. Basically, we have rules according to which the symbols are determined. Okay, bacha?
Okay, ma'am.
And
Yes, ma'am.
what's that rule? So the first letter, let's say we have hydrogen, okay, we take the first letter for this, that's H, okay. Then we say we have helium, okay. So how we will write helium? We will have the first letter as
H.
capital and the second letter will always be small letter, okay.
Small.
That is how we get this He. If you write He, it's wrong. If you write He, it's wrong, okay. This is the correct form. Clear?
Yes,
In
ma'am.
the similar manner, if I have chlorine, okay, because C has already been used for carbon, yes, I will
Yes,
have
ma'am.
chlorine as C and small l. Okay,
Okay, ma'am.
clear? Now, for
Yes.
some elements, the name which was there initially, example, we have this symbol for sodium. What is it?
Na.
Don't have sodium, right? We should have had S or SO, right? Like this. But
Yes,
this
ma'am.
simply is a name that was there initially. That means natrium. Okay, it is natrium. Natrium. Okay. We have potassium. We have K for potassium. Now, had it been potassium, it should have been P or Pa small a. Yes, but this
Yes,
refers to gallium.
gallium.
Okay, clear.
Yes, ma'am. It is
And
clear.
in the similar way, we have Fe for iron. Yes. So we have
Yes, ma'am.
different, we have symbols, I mean letters as symbols, either the first letter or the first two letters of the name of the elements as its symbols in the modern day sciences, modern day chemistry. And this is the standard symbol. Okay. Is it clear, Harshita?
Yes, ma'am. It is
I'm
clear.
quickly going through the NCERT to tell you one thing.
Yes, ma'am.
Hmm. Yes. See, nowadays it's IUPAC. I don't know what's the problem here. You can please go through it. It's IUPAC, International Union of Pure and Applied Chemistry, which actually decides the name, guidelines, and therefore the symbols of the elements. Okay. So hydrogen H,
Yes.
aluminium will be capital A, small l. Okay. Cobalt, capital C, small o. Okay, bache.
Yes, ma'am.
Today we have discussed it till here. In the next class, hopefully, I will be starting from the atomic mass. Very, very, very important. So I would want you to revise all of this and